Today we're gonna look at how to get the most out of the 5202 Märklin turnout. Many of the turnouts you buy typically on eBay or wherever you find them secondhand, and they don't work properly. They sometimes fail, and which could be very annoying, especially when you have computer controlled control of your trains. So let's disassemble one here, remove the two screws, then the solenoid, which is the motor, which is moving the mechanism in the, check the spring so it's okay, desolder the cable going to the lamp, here on the solenoid there is a metal clip or a kind of plate which holds the inner part in place inside the plastic bobbin. The plastic bobbin is the part which they have wound the copper coil onto. So bend that slightly so it gets straight and pull out the metal parts. Here you can see that there are contaminations inside, which is adding to the friction when this is moving. So I use something that's available in Sweden. It's used to polish things, typically for car use. Autosol, the product is called. You probably have something similar wherever you live. So I'm trying to polish this so it gets the chrome look it should have. Don't use any sanding paper or anything rougher because the chromate might get damaged. Just a very nice polisher like this does the trick. So here you can see the difference. Now it's nice and shiny compared to and all of the contamination is gone. Then I typically I polish also with a wax, car wax. I use turtle wax, but it's definitely not a must. It's just something I happen to have in my garage. Look at this inside of the bobbin. You can see on the top that it has sunken down. You see that it's kind of concave inwards. This must not be too much. It happens when the coil is powered too long at too high voltage, then actually the bobbin melts. So have a look at that. If it seems like it has it's sluggish in the moving and it doesn't really want to turn, then that might be the problem. It's not much to do about it. I've been trying to various methods to get away with that, get rid of it, but I haven't succeeded. So to be honest, I sell those switches back out on eBay again. Who said that? I didn't. Okay, here I polish also the other parts of the mechanism. Assemble it together again, checking that it's moving easily. So, time to insert it into the plastic bobbin again. There you go. Oh, and put the cable in place. It's tricky. And solder it back so we get light into our little semaphore again. I'm typically replacing the lamps with LED, but well, it's to reduce the power consumption. The power consumption just gets tremendous if you have a big number of turnouts on your layout. I will come to that in a later tutorial. How to make a LED module nice and neat and well working. So now it's time to assemble this switch again, see how we succeeded or not. I tested this particular turnout with a DC power supply at 13 volts and it didn't operate at 13 volts. So my goal is to have them to operate at 11 volts, because if they operate at 11 volts they will always operate. So here's 11 volts and it's working. So we reduced the friction by polishing and waxing the surfaces, and that really did the trick with this turnout. It didn't have any other mechanical problems, so it's just to put it together again, and there we go. Okay, thank you for watching.